So we will be looking at databases in multiple applications. RDI is one of them. Green screen is another one. And then you will be learning about a new application today, which is called the Run SQL script, which is accessible via ACS. So we'll be looking at that. So our main focus today will be to work with databases. Database, I don't know, did we talk about databases last week or no?
I don't think so. No.
Okay. So database, what exactly is a database? It's a place where data is organized in a fashion where it is so much easier for you to retrieve it, update it, insert new data, remove existing data. It's just a repository where you can perform several operations on the data. How is this data organized? Instead of physical files, the data is organized in tables. These tables are linked with special keys. We call them primary keys and forward keys. Now in physical files, you guys learn about keys. What was the role of a key in physical file? Anyone? Role of a key in physical files.
Would that be a field you can use to like organize what data is in there in a physical file?
Nope. Right at the beginning of chapter 8, the first 2 pages of chapter 8, I would say first 3 pages of chapter 8. If you have your books, open it and see what it says. Which topics is it talking about? Once you find the answer, share with us. Nobody found it yet? It's right there. What is the purpose of the key in the physical files? So you want me to open the book and find it for you. Is that what you guys doing to me now? It's not good. Okay, who will tell me what is the topic on first page in chapter 8? Okay, the first topic is access paths. Okay. What is the first subtopic under access path? Nathan, what kind of access path does the first page in chapter 8 talks about?
Arrival sequence.
Arrival sequence. Okay. DAR, what kind of access path page 329 talks about?
What'd you say?
I said, is today Monday or Tuesday?
Tuesday.
Okay, you heard that. Okay. My question to you was that what kind of access path is being talked about on page 329? What is that heading on page 329?
Keyed sequence.
Which one?
Keyed sequence.
Keyed sequence access path. Okay, is let's say Pamela, what's the difference between the arrival sequence and keyed sequence?
All right, so the arrival has to do with accessing in the order it arrived there
Okay,
versus, so in the order in which they were added to the file.
that's the arrival sequence. Okay, okay, what's a keyed sequence?
Sequence is, it's in that where you could access it by a specific key.
So you're basically, your system creates a mechanism for faster retrieval of data.
That sounds good. You always put it in better words than I can.
So that's the sole purpose of key in physical files. That's about it. But when it comes to tables in the databases, when we say a key field, we're not just talking about a mechanism of retrieval, which is done with the help of indexing, but we're talking about further categorizations of keys. When you say the table is keyed, right away you're telling the table has a primary key. A primary key automatically enforces indexing and automatically enforces unique value for the field on which it is imposed. So here in the physical file, when you key a field, it doesn't all automatically makes it unique. So if you look at page 331, figure 8.1, you will see that we have a unique in the top right corner, and we got the key at the bottom on the very last line. The combination of them makes it unique and the key. However, in the tables, when you say a field is a primary key, it's a combination of both and beyond and more. So primary key automatically means what? The field is indexed exactly like physical file, and the field will only have unique values. 2 rules done. Third rule, the key will now let this table connect the records with the data in another table. It will now let the table connect the data with another table, like something you did with logical file. A logical file last week, if you remember, allowed data from multiple physical files to be joined. You do not need to go at the logical level anymore to join the data sets. You can do it at the table level. You can join the data sets right at the table level. So right at the table creation time, you can identify a field which will act as an entry point into a record set. And you will identify that as a primary key. For example, your table at Gateway has a primary key of student ID. Wherever you go in Gateway, you are identified by your primary key, which is your student ID. How do you log into Blackboard? Your student ID, right? Okay. Your student ID card, by the way, can also be used for what else besides being used on Gateway? Your ID card has a lot of value. I don't know how many of you know where else you can use it besides Gateway.
Like for voting?
Yeah. It can be used as your voter ID. Correct. So it's your identification, your unique identification that is only given to you. So primary key allows a record to be connected with the other data sets outside of the table. And that will be one of our focal points for today. Okay. Does anybody has any question about the primary key? I suppose that's no. Okay. So when primary key is to be connected to with another table in and it would have a field to which it will do the connection, and that field will have the same specifications as the primary key. So if primary key is character size 4, the connecting field will also be character size 4. Also, the primary key and the field that you're connecting with in a different table, they must have the same data set. You cannot have a value in the connecting field which you do not have in the primary key. For example, how would you feel if you are working at the registration office, registrar's office at Gateway, and a student shows up to make a payment, and the student is only found in the accounts table and cannot be located elsewhere? I mean, like, what would be your reaction? How would you react to a person who is making a payment and that's the only place the person exists for a Gateway?
Oh, I'd be frustrated.
My first question would be, what are you paying for?
True.
Because I don't see you anywhere in the academics area. I do not see you anywhere in the student information area. So you're just here in the accounts table for what? Right? What are you making? I can't locate you as to what services we provided you that you are making payment for. So that's why it's very important for the data to be linked. And in order for it to be linked, it needs to follow some set of rules. So in order for any student to exist anywhere else, it needs to first exist in the primary table. That's basically the bottom line here. Okay, so that's what the primary key does. So this additional field, which is in another table representing the primary key, is called a foreign key. It's called a
Foreign key.
Foreign key. Okay. Why is it called a foreign key? For the same reason, if let's say Ismail, American citizen, goes to Canada. Okay. What do the Canadians start calling Ismail? He is a foreigner. Okay, why? Because he represents somebody else, not this country. Exactly the same way the field that the table uses to connect with another table is called a foreign key because it is there to represent somebody else. It doesn't really has any place in the existing table otherwise, other than a link. That's why it's called a foreign key. Okay. Now, if you are looking at page 331, you see a lot of fields. Okay. What do all fields have in common? Page 331. Yeah, go ahead, Dar. Go ahead.
Other fields?
Of course. Besides that, what do they have in common? All of your students, is there anything common between you guys? Is there anything that all of you have in terms of your representation as an individual?
They're unique.
Yeah, but do you have anything that everybody also has? I'm talking in terms of representation, not physical biological entities. I'm talking in terms of being represented in data. Here you go. Smile wrote something in the chat. Can everybody read that? Right? What else? What else is common between all of you?
We've all got names in the system.
You all have names, right? Exactly. You all have some place you stay. You all have an address. You all have some way of getting in touch with you, whatever it is. So there are some common behaviors or common properties that you all share. So what are some of the common things that these fields share with each other on page 331? Of course, good job, Ms. Smile. They all have names. They all have data types. And if needed, they all have sizes, right? So when you take this idea to the tables will also have fields. The fields will have names. The names will have types. And the name will have a field size. Does that make sense to you guys? Or you are thinking turkey? No, okay, cool. Okay. Like, oh my God, the instructor looked like turkey. I don't know why he's doing gobble, gobble. I don't understand a single word that is coming out of his mouth. Okay, as long as you are not in that phase, I'm good. You know, I had one college professor when I was in university, and we asked him when we all came back from Thanksgiving break, and like, professor, did you cook any turkey? He said no. And we're like, why? He said, because the turkey I got was big. He was a funny guy. The turkey I got was big. It wouldn't fit in my oven. And we're like, why didn't you cook it sideways? He's like, oh, I've never seen a turkey getting cooked sideways, so I never cooked one. He was one strange guy, but yeah. So are a lot of people. And I mean, like, it was a joke among us when we were going to school. A lot of these guys who get their PhDs get a little cuckoo up there. Anyway, that were we. So, with this knowledge, we will now be transitioning into the V2 Cloud. So when you guys are in V2 Cloud, please let me know. And we will then start our today's class with our tools and utilities and what and what not. Okay, awesome. Awesome. So when you guys are in V2 Cloud, open RDI, Rational Developer Fry. Nathan, you got in, right? Into the V2 Cloud. And Dar, are you in the process of logging into? Oh, you are in? Okay. Okay. So Nathan, you're into?
I'm in a process.
Oh, you're in the process. Okay. 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 Let me know when you are in V2 Cloud and you have open RDI. And then I'll tell you what to do next.
All right, I'm in now.
Okay. I don't know if Nathan got it or no.
I mean, how do you get into that screen again?
That is something I will show you guys. I'm just asking everybody to just get into the RDI for now. I don't know. I think I saw Nathan give me a green check, but then I don't know if he did or not, or if he still is in the process.
Yeah, I'm sorry about that. I logged in and then it kicked me out and I was having issues, but I'm in right now.
Okay, awesome. So all of you probably may not remember how to get to the green screen from the RDI, but let me show you again how to do this. So you have to be in the Remote System Explorer, which is RSE environment. In the Remote System Explorer environment, you can hit close on it if it gives you this option, enter a password, okay? Scroll up to right at the top where you see deathstar.gtc.edu in the Remote System Explorer. That's where you right click on it and you choose Host Connection Emulator. When you click on Host Connection Emulator, as soon as you click on it, you will see the green screen environment loading in your RDI. Okay, everybody got it? Dar, did you find it?
Yeah, I found it.
Okay, cool. And then you guys can use this bottom separator to push it down to increase the font size. So as the window size increases, so does the font size. Okay, now you can log in here with the same credentials that you typically log in, but you're now in the green screen. Okay, everybody got it? Now here in the green screen environment, we type STRSQL to open the SQL environment. I am running some SQL here to show you. Let's say if I had a table called manufacturer, okay? So I'm typing an SQL command. I want to drop a table called manufacturer. And I hit enter, and it'll tell me that the following table was not found. That's why I can't delete it. Okay, why? Because I misspelled manufacturer. Okay, so let me use the insert key to enter the correct spelling. Manufacturer, turn off, enter. Now it tells me the table was dropped. So I just wanted to show you if you enter a command and it figures out that what you have entered has an error, it will tell you right away. If it did not have error, it'll just walk you through the whole process. Let me try again. So if I want to type another drop command, I'll just press F9 and I'll get my drop command again. And let me drop a table called medication. And here you go. Medication table is gone. So that's how I can run this environment. I type a command and I hit enter. The command goes through if it doesn't have any mistakes. If it has any mistakes, the system will yell back and say, you know what, you made a mistake and you need to fix it. Now, did you guys notice one thing? When I type drop table manufacturer, what did it say? Drop off menu 00001. But when I said drop table medication, it said drop off medication. Why do you think it did that? Anybody? Why do you think it behaved differently for the two tables? And they are both tables. They're both database tables. What is the maximum size or length of characters for an object? 10. How many letters does manufacturer has? Exactly. So database tables can be more than 10 characters long, but the system objects cannot be more than 10 characters long. So if the name of the table is longer than 10, then the system creates two names, a short name and the original name. Medication was within the bound, so it didn't have a short name. And manufacturer was more than 10, so it had a short name and also had its original name. So that's basically what the difference between the two is. Okay. Now I want you to go back to the Blackboard. We will come back here. We'll come back here. Go to the Blackboard. And on Blackboard, go down to unit number 11, which is about databases. Okay. Now, if you scroll down here in the list, you will see that I've given you YouTube database tutorials that I created. This is a folder, you click on it, and it just walks you through a couple of tutorials about what is a database and what's an SQL kind of stuff. And if you scroll down, you will find another folder called Notes and Documents. You click on it to open, and it tells you a few definitions of what is an SQL. SQL is a language with which you communicate with the database, and the database technology that we are using is relational database, where database has tables and those tables are linked with each other, and these linked entities are called relational databases. These relational databases comprise of tables. Tables are also called relations. These tables comprises of rows and columns, and rows, which are also called records, are also called tuple. And columns, which are also called field, are also called attributes. So a database table is similar to a spreadsheet, not exactly the same as a spreadsheet. We use a language called SQL to work with it. SQL is heavily command-based. In order for you to communicate with the database using SQL, you need to have a command. These commands are then categorized into different categories: DDL, DML, DCL, DQL. If you want to create an object, objects are permanent until you delete them, unless you delete them. So objects are created with the command create. Objects are modified with the command alter, and objects are removed with the command drop. And that's why I use the command drop to remove two objects, manufacturer and medication. They're permanently gone along with their data. Okay, so objects creation, object modification, object removal, all these jobs are done by the DDL command. On the contrary, the DML command work with the data in the object, such as putting new data in the object, which is insert. Modifying existing data in the object, which is update. Removing existing data from the object, which is delete. And if I were to work with permissions, like giving somebody permission, taking away somebody's permission, that's grant and revoke commands. And finally, a select command, which will help me select the data in the tables. So that's a basic breakdown of the SQL commands. Does anybody has any questions about this breakdown and the commands? Okay, next. DB2 UDB, unlike physical file, has a wide variety of data types. It doesn't have like packed and zone and character and only a handful of them. Rather, it has top level demarcation of built-in types: external data, date, time, string, and signed numbers. And that's top level. Okay. Then date time is further divided into time, that's a valid data type, date time, that's a valid type, and date. String is further divided into three types: character, graphics, and varying length binary large objects, which is mainly used for storing audio, video files, images, that kind of stuff. Graphic, on the other hand, is more inclined towards images. So graphic could be fixed length if all images are of the same size, or varying length if they are of the different sizes, but you can always give a max. Character, on the other hand, could be fixed length, just like graphics. In that case, it is called character. If it is varying size, it is variable character. For example, phone numbers are fixed size. Everybody's phone number is 10 digits long. Social Security is fixed size, but names are not. Addresses are not. So if I'm storing varying length types, varying length data, then my type will be variable character. If I'm storing fixed length data, the field type will be character. And then the character large objects is generally used for storing large amounts of data. For example, if you want to store like a dictionary, or the entire essay about something. On the other hand, we have exact and approximate. Exact then goes into binary integer, which then gets divided into small int, integer, big int, and decimal, which is packed, but it's called decimal in this operating system. And in the approximate, we get a floating point, which is real and double. Okay. Now, let me ask you this question. All of you are taking Intro to Programming this semester, is that correct? Or have taken it before?
Have taken it, yeah.
Okay. Anybody here who's not taking Intro to Programming? Oh, you have not. Okay. Okay. So basically, we should then ask you the question, because it is about it is about Intro to Programming class. So we will ask, right? No, I'm just kidding. No, we shouldn't ask you. We should ask those who have taken it, right? Okay. So, which data type in C# is equivalent to small int? Which is basically called, no, not int. Int is integer, 32-bit, which is 4 bytes. Short is basically int 16, 2 bytes. And long is big int, 64-bit, 8 bytes. Okay. Yeah, so you have used int 16, correct? So that int 16 is also called short type, or int 32 is basically the int, and int 64 will be the big int. But if you go to other languages like Java, Java calls small int short. It calls integer int, just like C#, and calls big int long. Okay. Now, with this explanation, I want you to read a few documents. I want you to read this document under number types, and then read this document under date time values. After you're done reading these two documents, let me know if you have any questions. And if you don't, then give me a green check. Okay, two of you are done reading. Let me know when other people get done reading as well. Dar, you're done reading too, or are you still reading? So for those of you who are done reading, do you have any questions? Okay. Oh, you have lots of questions. Okay, go ahead.
I guess I'm just most confused on all the ranges,
Okay.
like data types and like what the E stands for. And
Okay, so which one? The numbers data type you're talking about?
yeah.
Okay.
Yes.
So for example, if it's a small integer, that means small integer data type can only hold values that are between negative 32,768 to positive 32,767. If your value is larger than that or smaller than that, then you should switch over to integer, which supports a value from negative 2 million to positive, sorry, negative 2 billion to positive 2 billion. And if your value is over 2 billion positive or less than negative 2 billion, then you're better off using big integer. Okay, and now these over here under the single precision floating point, these are in scientific notations. That means this is 38 digits long. Okay, including or excluding the number of decimal places. Total 38 digits are allocated for it. So this is like 3.4 times 10 to the power of 38. That's what the value is, from negative to positive 3.402 times 10 to the power of 38. So that's the scientific notation. And then we have similar scientific notation for double precision that is even more precise than the real. And the decimal and the decimal is scale where the total number of digits are the maximum 31 digits in precision. So the position of the decimal point is determined by the precision and the scale of a number. The scale, which is the number of digits in the fractional part of the number. So if it is 3.572, so 572 is the scale. And that scale cannot be negative or greater than the precision. So the maximum precision allowed is 31 digits. And then all values in decimal column have the same precision and scale. The range of the decimal variable or the numbers in a decimal column is negative whatever value to positive whatever value, where the absolute value n is the largest number that can be represented with the applicable precision and scale. So this is the maximum range where you have a number which is -10 to the power of 31. Whatever that number comes out to +1, that's a min range. And 10 to the power of 31, whatever that number is -1, that is the maximum range. So it's just like massive ranges in which you can put the values in. So that's what basically the number data type represents. If you're talking about the date time values, then that is basically showing you the date, which could be in 3 parts: year, month, and day. The internal representation of the date is 10 bytes. That means 4 bytes for the year, 2 for the month, 2 for the date, and 2 for the hyphens in between. So a total of 10 characters represents 1 date. Time, on the other hand, is represented differently. So a time is a 3-part value where you have hour, minute, and seconds, designating a time of day under a 24-hour clock. The range of the hour part is 0 to 24. The range of the other parts are 0 to 59 because you have maximum 59 in the minutes or seconds, and then it turns to the next one. So the internal representation of time is a string of 3 bytes where each byte represents one of the 3 parts. Each byte consists of 2 packed decimal digits. The first byte represents the hour, the second byte represents the minute, and the third byte represents the second. And then the timestamp comes, which includes additional information, which is going up to microsecond. So that internal representation of timestamp is 10 bytes. So it has year, month, day, hour, minute, second. So that's why it goes. So each byte consists of 2 packed decimals. First 4 represent the date. The next 3 represent the time. So that's 7. And the last 3 represents the microsecond. So that's basically the date time representation. And then we will be typically following the ISO format here, which is you will be entering date in this format here on our system, which is year first, then month, then date. Of course, and then there are other formats also, like IBM USA standard format, IBM European standard format, Japanese industrial standard Christian era format, and then we have site defined, whatever the company wants. Similarly, we have time strings, which is not just the timestamp, but rather you want additional information with it. So a string representation of time is basically a string that starts with digit and has a length of 4 characters. Trailing blanks may be included. A leading 0 may be omitted from the part of the hour, the time, and the second. If seconds are omitted, an implicit specification of 0 is assumed. So for example, 1330 is basically equal to 1330:00. These are some of the valid string formats where you would be able to add things like AM, PM kind of stuff. That's what basically the string formats are. And similarly, you have timestamp string formats, very similar to the time string format. So that's what basically these two documents represents. Okay. Moving on to the next concept, which is about constraints. As I said earlier in today's class, that when you have a primary key and a foreign key relationship between two tables, foreign key cannot have any value that is not in the primary key. For example, we have an artist table. The artist table has artist IDs and it has artist names. The other table is the album information. Now, each album is, it belongs to one of the artists, right? So if the album number 1 says that I was sung by artist number 3, and artist number 3 can be located in the table, album number 2 says I was sung by artist number 4, and artist number 4 is nowhere to be located in the primary table. So that's a constraint violation. That's the integrity constraint violation. So primary key and foreign key, when they are put together, do not allow for a constraint violation. Okay. Now moving on to a good example. Here we have a category table where we have category IDs for each category. Now we have an items table. In the items table, each item is placed in a category. The item cannot be placed in a category which doesn't exist in the category table. So item 1 is in category 1, good. Item 2 is in category 1, good. Item 3 is in category 3, good. So none of the categories are outside of the bounds. So that will just go perfectly fine. Does that make sense to you guys? The constraints, the integrity constraint stuff, what it implies? So if you click on the constraint document, it basically talks about the primary key constraints and it talks about the referential constraints. I want you to go over this document. Even though there are some steps, don't worry about the steps. Just read page number 1 and read page number 2. Forget about the steps. Don't go into steps. Don't read the steps, just read the basic definitions. The primary table, the referential constraints, the constraints prerequisites. So as I said earlier, the primary key is a constraint which not only enforces you to have a unique value, but it also defines as a way for you to identify the column and connect it with others across the board. It represents a value which must be unique for all the records within a table. The column must be in ascending order, and it can be null capable, but traditionally primary keys do not allow for nulls. On the other hand, we have relationship constraint, which is on the grounds of referential integrity, which creates a relationship between the dependent table and the primary table, the parent table where the primary key exists, and the dependent table where the foreign key exists. And the system guarantees that for each row independent table with a non-null value, there must be a link to the parent key in the parent table, which is the primary key. And after you set up these business rules, then the constraints apply. Anyway, now let's move back to whatever that is here. Here. Okay. Now, after we're done with this, let's go back to unit number 11. And in unit number 11, there are a couple of other resources for you guys to tap into. One is the SQL tutorial PDF. This is a short PDF, 30 pages, which talks about some basics of SQL. And then there is a link to the actual database, DB2 UDB online SQL tutorial. So when you click on it, it takes you to a tutorial about DB2 basics. And on the right-hand side, you can see topics like select, you can see topics like insert, update, delete. All of these different topics are being dealt with in this tutorial, okay? So there will be 2 assignments assigned to you this week, by the way. Since we are here, let me talk about that. One is based on joins that we covered last week. If you remember, the last two assignments, you have been using publisher and books table, which is populated with the data. So the top part, you already should have completed by now. Now the bottom part is, now you are creating a logical file called book info 4, in which you will join the two physical files together and will display the following fields from the two physical files in the join table, in the joined logical file. So that's what this assignment is. Very, very important assignment. I'm telling you now, there will be a problem on the final exam where you will be asked to create physical files, populate them with data, and then create a logical file to join the data from the two physical files. So we looked at it in class last week. We solved the in-class problems. And then I am giving you an assignment this week as a way for you to recall that. And we covered that in chapter number 8 as to how you go about joining the physical files in a logical file. Again, your point of reference should be pages 358, 359. 358 shows you the physical files, and 359 shows you how those physical files are joined in a logical file. Okay.
Why should you use Miro?
Okay. Just 1 second. Does anybody has any questions, by the way, about the assignment number 1 that is assigned to you now? The first one. As I said, it's very important for you to know the hands-on stuff because it's directly linked with your final exam.
Are you talking about questions that we have about the assignment from tonight, or the one the new
No,
one?
no, the one I'm talking about right now. Not from tonight, yeah. But tonight's assignment will play a vital role in completing this one. And the last week's assignment played a vital role in completing today's assignment, because 2 weeks ago, you created these tables and populated them with data, right? So last week's assignment was about creating logical files on the data set that you created 2 weeks ago. And this week's assignment, the new assignment, is about creating a joined logical file on the same data set. So do you have any question about this assignment? Is what I'm talking about. So do you have any questions about what the assignment that's due tonight?
I had a question about what was due tonight, but I was going to ask you after class. Just
Yeah, okay, sure, that's fine. Okay. The second question for the second assignment that is given to you tonight is that you can think of an object. You will write that object's properties down, and then you will assign each property an appropriate data type, a field size, and then you will convert that idea into an actual table, and you will insert data in that table, and then you will give me the SQL for creating the table and SQL for inserting the data. So that's what this assignment is about, which we will now do so that you will see. We will do something very similar to the assignment that I'm giving you. So you will now create a database table for the object. Add all object properties as table fields. Each field will have a data type and a field length. Then add 4 records to this table using SQL, and create a database table using SQL, and provides a screenshot of your table SQL. Create and insert commands and screenshot of the table in RDI's Data Explorer. Okay, so we will then look into that. So now let's say I am creating a brand new document. And in this brand new document, let's say I want to create an object. Give me a name of an object. About which we want to store data. Classroom. Okay. Classroom. That's the name of the object. Okay. Ismail, since you gave me the object name, can you tell me one property about a class name or one field, some data that you would want to store about the classroom? Students. I mean, like, what do you mean? Can you elaborate more on it? What do you mean, students? You got to think in terms of, I want to store the data, right? No, that doesn't really make sense. Classroom and student ID doesn't really make sense. What do you, I mean, like, nobody stores data, student ID and classroom in the same table. Is that they're two different objects. They're not linked. You don't really put in a system that the following student ID is allowed in the following classroom and the following student ID is allowed in that class. You don't do that. So what was going through your mind when you picked classroom? Let me ask you that. What is it that you want to store about a classroom in the database? Okay. So we're going to get rid of the object name that you gave me. So give me an object name about which we want to store some data. For example, if somebody says the object name is shirt, I said, yeah, it makes sense. I can store the shirt's price, the shirt color, the shirt size. I can store some information about shirt. So shirt is an object, about which data can be stored. So give me an object about which we can store the data. So after we have the object name, we will start exploring what kind of data can be stored about that object. Laptop. Okay. Laptop. Okay. Give me one field to identify a laptop with. Model number. Okay, Pamela, give me another field to identify a laptop with.
How about like the size of the laptop?
Size, okay, like, laptops have 14-inch, 16-inch, 15-inch, whatever. Okay, cool. DAR, give me another field to identify the laptop with.
Um, the CPU.
Okay, so CPU. Okay. Nathan,
RAM.
RAM. Okay. Now going back to Ismail, what do you think would be a good data type for model number? And for the rest of you who gave me, I will ask you about the data type, data type and the size. So get thinking. So right now, I'm only asking, Ismail is saying, Ismail, this is not a physical file, remember? This is databases. So we don't use A in tables, right? That's for physical files. So when you say character, that doesn't really tell me much. Do you want to do fixed character or a variable character? Variable character, okay. So we'll use Markar, okay. What do you think is a good model number field size? Maximum number of characters you want to store for a model number. Some model numbers could have less, 12. Okay. Pamela. Size. What data type?
Variable?
Variable. What do you mean variable?
Wait. I'm trying to think like various sizes what I'm thinking, but
Remember I showed you guys a whole chart of data types on Blackboard under this week's unit where you had lots of questions, that chart. What data type do you think is more applicable for this data, for this field? It was inside the notes and documents. This one I'm talking about, this guy. So which data type do you think will apply for size?
You mean like the fixed length?
Fixed length graphics?
Just trying to see here. Hold on.
Why would you use graphic? The graphic is for pictures.
No, I just had like this laptop size is stuck in my head. So that's what I'm thinking. I'm looking at the chart. Hold on.
So sizes are typically what kind of values? Can you give me some examples of values for size? When you say size?
Oh, I'm thinking like size, like, like the size of the screen.
Right. Give me some examples.
Oh, like you mean like a 14-inch
Okay,
screen?
so 14, is that a date? Is that a time? Is that a character? Is that a graphic? Is it a number? What is 14? Well, which bucket would you put 14 in?
I guess you do character.
Character, 14, okay. So character, fixed or varying length?
I would do varying.
Varying length, okay. So we can have variable character. And what size?
Do you want a range of sizes or just one size?
No. I need like maximum field size so that any data could fit in. So for example, if I want to store 17.5 inches, so 17.5 inches, this whole thing will take how many characters?
3,
3?
4 if you count the decimal point.
Yes. 4, yes. Or if you want to go even like up to 2 precisions, then you will have 5. If somebody goes like 17.63, I'm just giving an example. So if you want to go up to 2 decimal places, then you will need 5. Okay. DAR, when you say CPU, give me examples and then pick a data type. Yes, DAR?
Like the Core i7.
Yeah, so
Core
Core
i9.
i7, is that a number or is that a text?
Is text.
Text. So for text, what are the choices do we have here? What is the equivalent of text here in DB2? Is it date? Is date equivalent of text?
No.
No. What about number?
No.
No. Graphics? Is graphics equivalent to text?
No.
No. Okay, so which data type?
Character.
Character. Okay. Now, varying or fixed?
Varying.
Varying. Okay. And What field size should we use here? Maximum number of characters.
Say 20.
20. Okay. Nathan, your choice. Your turn. What data type for RAM and what size?
So I guess if you assume it's going off of gigabytes, it could go into an integer.
Integer. But the problem is integers do not, oh yeah, you probably, okay, integer is fine. Okay, integer is okay. Okay, so that is the name of my object, and these are my properties. And these are my data types. So for the homework assignment also, you guys will think of an object, you will list the properties of the object, and then you will have the data type for each one of the property, and then you will gonna be doing the field length, and then you will convert that into an equivalent SQL, database table. Okay, so let's do that for this table. Okay, so let me bring up the V2 cloud environment here. Let me log in again. And let's go to the SQL. So everybody log into the green screen and type STR_SQL. STR_SQL. That is the utility that will take you into the SQL environment. STR_SQL. Okay, is everybody in this green screen STR_SQL utility? Okay, Pamela is, Nathan and Ismail is, Dar.
I'm there.
Okay, now the create table is a DB2 command, create, which is then followed by the name of the table that you want to create. For example, this is the syntax of creating a table. Create table followed by the table name. Then you open parentheses and you close parentheses. And between the open and the close parentheses, you start listing your fields. Each field has a data type, a comma, the next field starts, no comma after the last field. That's basically the syntax of creating a table. So here's an example. I want to create a table called sales customer. I start listing my fields. Fields are separated by commas, and each field has a data type and a field length and no comma after the last field. That's typically how we create them. So now, with that in mind, our table is what? Our table is laptop, right? Okay, so now I need to create the table called laptop. So I will type here, create table laptop. Okay, now let me do this. Let me first drop table laptop. I don't know if I have a table laptop before, maybe. So let me first drop it. You guys don't need to do this. I'll just do it. Yeah, okay, I don't have it, so that's good. Okay, cool. So now let me create it. Okay, so create table laptop. Now I start my parentheses. I can go to the next line. I don't have to write everything on the same line. I just don't hit enter. Just use the arrow keys to go to the Do the next line. Okay. What is the name of my field? Model number. Okay. No spaces in the field names. So I got here model number, varchar 12, comma, size, varchar, oops, size, varchar 5, CPU varchar 20, CPU varchar 20, and then I had RAM as integer, comma. Okay. I should have done one more thing. I didn't do it in this example to keep it simple. So no comma after the last field. Just simply close the parentheses. So create table name, open the parentheses, field, data type, field, data type, field, data type. Each field has a data type. Varchar has size. Integer, I did not put any size with it. I hit enter. Okay. It will tell me that the table was created, but was not journaled. Don't worry about journaling right now. So the table should be created if you had this query written out. So the query that I wrote was this. Make sure you type it correctly. I can actually try to take a snapshot of this and maybe zoom in. That's what you will be typing. Okay, let me know when you guys are done creating this one. And it basically gave you a message saying the following object was created. So Nathan got it, Ismail got it. Okay, we'll wait for Dar and Pamela.
Mine says created but not journaled. Is that
Yep,
it?
that's what it is supposed to say.
Okay.
Yeah, as long as it says that, you're fine. Dar, how about you?
I created.
Yeah, it created for you. It gave you the same warning, created, but was not.
No, I mean,
journaled.
how do you do that?
Oh, are you done typing all the way till the last parentheses?
Yeah.
Okay, all you do is hit enter.
Oh,
Got it?
wait a minute.
Okay.
Token var chart was not valid.
Okay, did you type
Oh,
chart together or two separate words?
put in var chart instead of var char,
Oh,
please. Created but not journaled.
yeah, that's it. That's fine.
Okay.
That's good. Okay.
We'll be back.
Yeah. So that's what I wanted everybody to do is to create that table, and it is created successfully. Now let's check to see that that table exists, even though it will be empty. So type select asterisks from laptop. Select asterisk from laptop. Asterisk means give me all the fields from the table laptop. And now you hit enter again. Okay, so when you hit enter, you should be able to see what I'm seeing over here, a blank screen with all the fields listed, no data found, because we never entered any data there. And you can hit F3 to come back to the screen. Everybody got this? Awesome. 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 So let's take a break here, guys. When we come back from the break, we will do one more example of creating an object, listing its fields, and converting that into a table. And we will also transition to a different utility for that activity. Besides green screen, we're going to transition to run SQL script. But I'll see you guys at 8 o'clock. And let me pause the recording here